modes of transfer. We shall see three types of modes of transferring the data, that is from input output to memory. The three types are programmed IO or program controlled, interrupt initiated or interrupt driven, and DMA. Okay, so we shall take the analogy of a teacher taking attendance in a class. So generally what teachers do is they ask for attendance to each and every student, like roll number 1, 2, 3 up to the strength of the class, that they are present or not, which if the class strength is more, it will take more time. So programmed IO is like the teacher taking the attendance in a general way by asking each student whether it is present or not. So in the analogy, the teacher's attendance sheet is the memory, teacher is the CPU, and the students who is giving information that yes, they are present or not, they are our input output devices. And for DMA we shall see that DMA chip is the CR or a monitor of the class. So programmed input output, what happens in this? Input output cannot IO devices cannot inform CPU regarding the data transfer. IO sets their own status when it wants to exchange information and waits for the CPU to ask. So this is the important point. All the input output, whether they are present, not exactly absent, if they are present, then they wait for the CPU, that they will wait for the teacher, that they will ask for attendance, then only you can give your attendance. So similarly here CPU will ask each and every IO device, do you have anything to transfer, do you have any data? So and if the input output device has any data to transfer, then it shall set its flag, transfer flag as true. Okay, so now CPU runs a program periodically, often known as polling, and checks the status of each device one by one. If any device has its status set, then it will transfer. So what are the disadvantage? Generally time is wasted. If the devices are more or number of student is more, then teacher has to ask each and everyone, so more time will be wasted of the class. So it is the wastage of CPU time. And then diagrammatically we can see we have a CPU here, we have the interface. In programmed IO we have a device interface that will store the flag of the device, input output device, and a data register or data buffer, like what data has to be transferred, that will be staying in this register. And then we have the control signal lines, address percent, um, address percent, data bus. So here time is needed to check the flag, this flag, and data means what, if it is true, then what means the time taken to transfer this data. So for multiple IO devices we will have multiple interfaces. Now time required in time required in programmed IO is time to transfer the status of the devices. Get the status of device means get this flag, and if it is true, then time required to transfer the data. So this can be written as we are getting the status of the data means we also need to transfer this flag also, right? So so the device takes time to transfer 1 byte of data, that is the status, and whatever data that has to be transferred. So this is programmed IO.